All right, hello everyone to another one of Mr. Martin's math videos. This is again a video for British Columbia Pre-Calculus 12. We are on Chapter 7 looking at exponential functions and Section 3 looking at exponential equations. So as mentioned at the beginning of the chapter, there's some pretty popular and well-known equations used in mathematics by mathematicians, scientists, economists, and biologists. Some of these include and even public health experts, as we've been discovering and hearing about a lot in the news with this COVID-19 pandemic here. But physicists have been using this to determine half-life of radioactive particles, population growth and decay, and then also one of my favorite equations, investment and loan growth. Okay, how money can grow exponentially, which is exciting. So solving such equations is not always an easy task, and the methods taught in this section work for a few special cases for exponential functions. The next chapter will teach you more comprehensive methods for solving exponential functions. So these two chapters, Chapter 7, Chapter 8, go very closely together. Okay. So example number 1 is building your intuition here. So the basic idea behind what you're learning today is that as long as the bases of two expressions are equal to each other, their exponents should be equal to each other as well, right? And that makes sense. If I were to say, what exponent would these two expressions be equal to each other, right? The obvious answer here, because their bases are the same, the obvious example would be that x would have to equal 2. Okay, so if the bases are the same, the exponents are equal to each other. You can come up with an equation with just dealing with the exponents and dropping the bases. Okay, and so that's a step towards helping us solve for these kinds of problems. So let's look at an example here. For this question, I have 2 to the power of 4x is equal to 2 to the power of 2x plus 6. Well, because their bases are equal to each other here, I know then that the exponents on those bases must be equal to each other as well. So I can simplify, I can move from this equation to this equation. All right, getting rid of the bases, nothing's in the exponent form. And then this is just, grade 9 algebra here, where I'm bring all my exponents to the same side. This gives me 2x is equal to 6. End up with x is equal to 3. Okay, so I've solved this exponential equation using this highlighted principle here. Okay, now sometimes, obviously it's gonna get harder than this. So what about this problem here? Here we have 4 to the power of x plus 2 is equal to 64 to the power of x. Okay? Well, in this situation, a 4 and 64 are obviously not equal to each other. Okay? However, they are both the result of when you have a power of 2. Right? If I were to change this 4 into 2 to the 2 instead of 4, right? X plus 2 is equal to 2 to the what gives you 64? Well, I know that it's a power of 2. Well, if 32 is 2 to the power of 5, then it must be 2 to the power of 6, right? 2 to the power of 6 gives me 64. So I'm going to substitute 64 with 2 to the power of 6. And of course, that is x. Okay? Now, now I have matching, well, not quite matching bases yet. First, I have to simplify the exponents, and then I'll have matching bases. So if you remember grade 9 and 10 exponential laws here, when it's a power of powers, right? So when a power is raised to a power, you multiply it together. So I end up with 2 to the 2x plus 4, right? That 2 gets distributed into this exponent, and then is equal to 2 to the 6x. Okay? because it's just 6 times x. All right, so, and now, again, I have matching bases. Therefore, I can make the exponents equal to each other. 2x plus 4 is equal to 6x. And then again, you just go to work. Minus 2x minus 2x. I end up with 4 is equal to 4x. X must be equal to 1. Okay? So a couple examples for that. So I want you guys to give this a shot here. You have your turn section in these notes right there. So go ahead and pause the video, give these a shot, and then we'll kind of regroup and come back together and solve these. Okay, so go. All right, hopefully these questions went well for you. All right, C, D, and E. So we're just going to take the same approach that we've been taking. Even though our bases don't match, they're both powers of 3 in this case, right? So I can substitute 3 squared in the place of 9 to the 4x is equal to, and this would be 3 cubed instead of 27, right? If you don't believe me, 3 to the 3, 27. Told you so. And then that's to the power to the x minus 1. Okay, and you can put brackets here if it's a binomial or something, just to remember that when it's a power of powers, then you're going to multiply the exponents that's raised to an exponent by each term in the polynomial there. So 2 times 4x is 8x is equal to 3 times x minus 1 is 3x minus 3. So from there, minus 3x minus 3x, I end up with 5x is equal to negative 3. Divide by 5, divide by 5. X is equal to negative 3 over 5. All right? So hopefully that one was an easy one. Okay, trying to get those matching bases by reducing those numbers into powers. Okay, matching powers. Or powers with matching bases, I should say. Okay. All right, so let's look at this one. Now here we have a base of 2 raised to the power of 2x, and then a fraction of 1 over 4 to the x minus 1. Okay, so here I need, again, matching bases here. So here I'm going to keep the 2x to the 2x, okay? And then here, instead of 1 over 4, okay, this might not be obvious here, but I'm going to substitute in the place of 1 over 4, I'm going to substitute 2 to the negative 2, okay? Because 1 over 4 is equal to 2 to the negative 2, right? If I have just a little exponents lesson again here, 2 to the negative 2, that's equal to 1 over 2 squared, which is equal to 1 over 4, right? So they are equivalent to each other, okay? What I'm substituting, and at the same time, I'm getting matching bases, okay? So both are covered as I want them to be, and then this is x minus 1. All right, and then from here, because I have matching bases, I can make my exponents equal to each other. So this is 2x, okay, and then again, that negative 2 needs to be distributed into this fraction here, which gives me negative 2x plus 2. All right, and then from there, plus 2x plus 2x, I get 4x is equal to 2. And then x is equal to 1/2. Okay? So that one, again, when you're seeing fractions, you got to see through it, okay? Work through that into these numbers with matching bases, but negative exponents to get that value that's equivalent to a fraction 1 over something, okay? So that is a tool that you have that you need to utilize. All right, here, 27 and 81 are both, exponents. If I have a base of 3 with various exponents, I can get to all of these numbers. So here, if I substitute 27 with 3 cubed, I want that green still, x minus 2. Is equal to, and 27 cubed would give me 81. 27 times 3 would give me 81. So this would be 3 to the 4. And then again, this is x plus 1. All right. I have matching bases, so I can drop the bases and I distribute my power of powers. So this is 3x minus 6 is equal to 4x plus 4. Okay, and again, minus 3x minus 3x minus 4 minus 4, and I end up with x is equal to negative 10. All right, so that's your final answer. Hopefully those questions went well for you. Okay, so that's kind of the essence of the math application of this chapter. We're going to look at one more question at the end that's a little bit harder than these. But getting those matching bases is super important when you're dealing with these types of questions. Okay? So let's see some actually real-world example for some of these numbers. So here, in terms of modern banking, example number 2, why you should never take bank advice from a person working at a bank. Okay? There's a lot of kind of conflicts of interest that these people deal with because a lot of them get commissioned for selling you certain bank products. So they get paid for making you sign up for things. And so those things might not be the best for you, but they're the best for your banker. So they're not always taking care of your best interests. So you want to know kind of some things about money before you just take advice from anyone from a bank or anyone on the internet for that matter. You want to do your research. So I'm going to show you 2 different options for investing your money, and you tell me which one makes most sense. Okay, so what the bank offers, this is very common. I just talked to a friend of mine about this, and his bank had advised him to invest in GICs. Ooh, GIC. And the GIC was offering, I think his was a little, probably more than this, maybe 3% instead of 1.5% interest rate compounded yearly, but still not very impressive in terms of an interest rate. And then so how much would this investment be worth after 5 years, 20 years, 40 years? Okay, well, the equation for this we saw earlier was A is equal to P, 1 plus the interest rate over the compounding period times the number of years, power to the number of years times the compounding periods. Okay, so here then A is the final amount that you're going to have, and P is the initial amount you're going to invest. Okay, so if I put in $1,000, all right, and now that is 1 plus, and my interest rate is 1.5. However, in math, percentages, we always want to apply them in decimal form of percent. So 0.015 over, here it's compounded yearly, so it's over 1. Okay, it's the amount of times that interest rate is going to be updated or applied throughout the year. Okay, and then to the number of years, so here my first example would just be 5 and then times 1 again. All right, so what is that going to give me? All right, see if this investment after 40 years is going to be worth it. All right, so here I have $1,000 times 1 plus 0.015 divided by 1, right? And then raised to the 5 times 1, okay? And I end up with, after 5 years, I have made a whopping $77 on my investment after 5 years. That's not very good. All right, but maybe time, investment, I've said this to you guys many times before, investment isn't always just about the amount, it's also about time in the market, right? And so what if maybe we look at 20 years or 40 years down the road at this interest rate? Maybe then we'll make some gains, okay? So if I take this same equation and I just change the exponent to 20 instead of 5, okay, now in 20 years, you've made, your $1,000 is now worth $1,346.86. So $300 instead of $77. So, okay, well, that's not nothing. And then after 40 years, change that 2 to a 4, okay? Now that $1,000 would be worth $1,800. So you haven't doubled your money by any means, but close to it, okay? But it took you 40 years to get there, which is a very long time. And, it's not a very good investment vehicle, okay? However, there's another way of investing, using more index funds, okay, which just follow the market and, include way less banking fees. And so less of your money goes into the pocket of banks and more goes into your own pocket because these index funds don't cost a lot to manage. Okay, so typically you can expect more between like 7 and 8% on these investments. So if we take the same equation with the same compounding period and everything, so 1 plus I over C, n times C. In this situation, I have 1,000. 1 plus 0.08 over 1 to the 5, okay? After 5 years, so I'm going to take this here, and I'm going to go over and change this to an 8 and delete that. Okay, after 5 years, I've already gotten more than what it would have taken 20 years at using a GIC as my investment vehicle. Okay, now your $1,000 after 5 years is worth $1,469.33. Okay, well that's not bad, right? But it's a start. But what about after? I'm not going to rewrite the whole thing. After 20 years or 40 years, what does it look like? Well, after 20 years, if you take this investment, now your $1,000 is worth $4,660.96. Okay, so your money has been multiplied. It has quadrupled and even more so, okay, after 40 years. Okay, well, that's exciting, right? That's, you've quadrupled your money and you haven't done anything. You earned that $1,000 and then that money went to work for you after that, okay? Which is what you want your money to do. You want your money to work for you, okay? You don't want to just work for money. You want money to work for you. But after 40 years, and this is why I stress time in the market for you guys, especially you young investors, young money earners, you start investing now. The power of compound interest is just incredible. After 40 years, that original $1,000 without adding anything to it is now worth $21,724.52. Okay? So that's a lot of money. And let's say instead of having solved $1,000 at the beginning, what if you were to save, insert $10,000 right from the beginning, okay? Then at the end of this, you have $217,000, okay? And if you're able to, save $100,000 and still have 40 years of time in the market, okay, you're looking at that money being worth over $2 million in 40 years, okay? Now, $100,000 is a lot of money to have invested by 25 when you're 25, but this is what we're talking about, right? 40 years in the market and retirement at 65, that's at 25 years old. I think each and every one of you guys can have at least that $10,000 in your account by the time you're 25, and then go from there and keep adding as well to your investment. Okay, so the conclusion is that sometimes bank advice isn't always the best advice. That's the conclusion there. Okay, we can also another kind of application, or furthering this application for finances here. So is this problem here. So example 3, saving money with compound interest. Christina plans to buy a car. She saved $5,000. The car she wants costs $5,900. How long will Christina have to invest her money in a term deposit that pays 6.12% per year, compounded quarterly, before she has enough money to buy the car. Okay, so same equation again. A is equal to P, 1 plus I over C, N times C. Okay, oops. So again, we want to know the final amount that she needs to have is $5,900. Okay? The initial amount she has is $5,000. Now we're solving for a different part of this equation, right? And then here it's 1 plus the interest rate in decimal form, so 0.0612 over, now it's compounded quarterly, okay, which is one of the possible compounding periods. Sometimes it's annually, sometimes it's quarterly, sometimes it's monthly. Those are the main ones. It's very rarely daily or weekly, but if you can, the more compounding periods, the better. But it doesn't make a huge difference. So here, compounded quarterly, that means there are 4 quarters in a year, so you would put a 4 here. Okay, this would be a 4 in C. Okay, for monthly it would be 12, semi-annually would be 2, annually is 1, weekly would be 52, and daily would be 365.25 that you would put in the place of C. Okay? And then we're solving for N, but again, it's N times C, right? So it's N times 4. Okay, that 4 has to be applied. That quarterly has to be applied in both of those places. Okay? Now we can simplify this equation a little bit. I can divide both sides by 5,000. And that's going to give me 1.18 is equal to, and then I can simplify what's inside here. And that's going to equal 1 plus 0.0612 divided by 4. Bracket that. And I get 1.0153, and then this is to the 4n. Okay? Now, sometimes it's helpful to solve this equation by just substituting x in the place of the exponent and understanding that x is equal to 4n. Okay, so if I say that 1.18 is equal to 1.0153 to the x, then I can actually solve this. There's a couple methods here you can use. You can use the guess. Next chapter, we're going to learn the better method. But for now, you can use the guess and check method. Or you can graph it. Okay? Or you can graph it. And I would recommend that you graph it, especially since you guys are graphing calculator wielders. You have those skills. So y1 is equal to 1.18. y2 is equal to 1.0153 to the exponent of x. And then you just see where those two lines meet when you graph your line. Okay? And lo and behold, they meet right there. So x is equal to 10.9. Okay? So x is equal to 10.9. Okay. However, I know that 4n is equal to x, right? And so 4n is equal to 10.9 divided by 4, n is equal to 2.73 years. Okay? All right, those 10.9, that 10.9, that's in quarters. So you have to wait 11 quarters essentially to get the money, which represents 11 quarters would be 2 years, which is 8 quarters. It'd be 2.75 years. Okay, almost 3 years. 2 3/4 years. Okay, so that would be your answer there. Okay, she's better off just putting aside more money each month to try to save it on her own instead of letting interest grow. Short-term kind of stuff, interest is not always very powerful, doesn't really seem that impressive, but when you're dealing with long-term investments, that's when really compounding interest can be really can really work in your favor. Okay? Last question here. I want you guys to give this a shot, just based on your understanding of exponent laws and exponential rules and even the A method. Hint, hint, nudge, nudge. See if you can solve this equation. Okay? So solving an exponential equation. This one's a little bit next level, but you guys have the tools you need to solve for it. So give it a shot. All right? Go and pause the video, and then we'll do it together. All right, I don't know how that went for you. Hopefully you guys learned some things. At least maybe, if nothing else, you learned what doesn't work, okay? And so here, in this situation here, what I'm trying to do, because it's equal to 0, right, is I'm trying to turn this into some kind of quadratic, and I can use the A method to substitute, right? So in this situation, what I'm trying to do here is, trying to make, 2x be equal to everything, have another 2x here, then I could substitute. Okay, I'll show you guys kind of how it goes. So the first thing I'm going to do is I'm going to change this first one into 2. Sorry, this is going to be 2 to the 2x over 2 to the 1. Okay? Because if you guys remember your exponent rules, that's the difference of powers, right? When you have 2, to the 3 over 2 to the 2 is equal to 2 to the 3 minus 2, which is equal to 2 to the 1, right? So you subtract them. So here, all I did was I worked backwards, okay? I went from something in this form to something in this form, okay? And then this is minus, the rest doesn't change. 2x plus 64 is equal to 0, okay? And to get rid of my denominator here, I get to multiply both sides by that 2, okay? So I'm going to multiply this by 2, and I'll multiply this side by 2, okay? What that gives me is 2 to the 2x minus, now that this 2 has to be distributed, right, into each position, minus 24, right, 2 times 12, 2 times negative 12 is negative 24, to the 2x, plus 128 is equal to 0. All right, so that's the first step. But I still don't have matching powers here, okay? But I'm almost there because I also know that I can split that 2 to the 2x into 2 to the x squared. And I hope when you see that, you say to yourself, aha, that's the ticket. That's the trick right there. That's what I missed if you didn't figure this out on your own. Okay? Because now notice that we have 2x and 2x here, and 1 is to the power, is to the degree of 2, and the other one is to the degree of 1. Okay? So now I can use the A method and substitute, because I can say A is equal to 2x and substitute A in the place of 2x, which is what I'm going to do now. Okay? So I get A squared minus 24A plus 128 is equal to 0. Okay? Now, product and sum, what are two numbers added together that give me negative 24 and multiplied together give me positive 28. Right, product is 128. Sum is negative 24. Here I think A to the negative 16 and A to the negative 8 is our solution for this one. Okay, which means that A is equal to 16 and A is equal to 8. Okay, now A is not equal to A, right? A is equal to 2x. So now I substitute, and sorry, this is not 2x, this is 2 to the x. Okay, now I substitute 2 to the x back into my equation. Okay, so now I say, no, A is not equal to 16. 2 to the x is equal to 16. and 2 to the x is equal to 8. Okay? And in this situation, hopefully you can figure out what x is equal to, right? What power do you need to put on 2 to get 16? Well, x here is equal to 4. Okay? And what power on 2 do you need to get to 8? That's x is equal to 3. And that would be your 2 solutions. Okay? Kind of a rough equation. Okay, the key here was to be able to work backwards from some of the exponent laws that you know already. Okay, both the difference in powers that we did at this step here, all right, or the power of powers like we did at this step here. Okay, and then using the A method to then solve that quadratic relationship there. Okay. My battery is dying, and I've been at the end of the notes. Your homework assignment is at the bottom here, due Monday. Hope this video has been helpful for you. If you have any questions, drop them in the homework questions channel of the Teams chat or in the comments, and I'll try to get back to you as soon as I can. Goodbye.